You see what's happening in our school systems today. How in the world are our youth ever going to have a chance to learn the true science if they're not willing to teach it? Why can't the evolution model simply teach all the science and let students do critical thinking and come to a conclusion? Why must evolution consistently give misleading information or leave out information called deception by omission? You see, any model that's going to call themselves scientific or even call themselves a theory has to be able to present all the scientific information. If they're unwilling to do that, they no longer qualify as a theory or as science. So what we're seeing here in our textbooks today is something called deception by omission. They are unwilling to allow our students today to see all the science. Now, just recently, 2003 here, they sent up another satellite to measure the background radiation of the universe. Now, what they're measuring is something called the cosmic microwave background radiation. Now, what we mean by that, let me give you an illustration, this background radiation. You have a fireplace, and you've had your fireplace going for hours and hours and hours, and then you turn it off. What happens to those coals or wood in there? Those coals gradually cool down, gradually cool and cool, and you see them turning from a bright orange back to the original color. So it's gradually getting cooler and cooler, and finally you see the last dying embers of the heat that was in that fireplace. That's what we mean by the cosmic microwave background radiation. It is supposed to be the last dying embers, the last heat left over from that tremendous Big Bang explosion about 13.5 billion years ago. So they sent this satellite up there to get a map of the heat and this cosmic microwave background radiation throughout the universe. And here's what they had to say after they sent it up. The most detailed and precise map yet produced of the universe at its birth confirms the Big Bang theory in triumphant detail. It reveals the emergence of the first stars in the cosmos only 200 million years after the Big Bang. 500 million years earlier than theorists had thought. Now, first of all, that statement. Did they show anything different? No, they didn't. They had already had a previous satellite went up there and mapped this whole universe with the cosmic microwave background radiation. All this one did was give us a clearer picture. So it gave us nothing new but a clearer picture. Then notice that statement, emergence of the first stars. Notice nowhere do they say how that happened. They're making a claim with no supporting evidence. That is called faith. We need to be keeping science to the science classroom. I already have a faith. Why should I accept the faith of evolution when we already have one? Why only teach one faith? Why not all the faiths? Why should we be forced into learning just one faith called evolution? So again, a claim without any supporting evidence. Finally, conclusion on star formation. Marcus Chown, in his book, Let There Be Light, his article, Let There Be Light in New Scientist, says this. The truth is that we don't understand star formation at the fundamental level. So the question is, why do textbooks continue to state we know how stars form? The only reason we can come up with is the scientific evidence does not matter. All that matters is we believe in evolution. So we've looked at the two models. We looked at evidence of age. We looked at the origin of stars. Now let's look at scientific evidence and the Big Bang. And again, the statement, are we being given all the evidence or just selected information to support a particular idea? And here's another question. Evidence in the Big Bang. Are the evidences used to support the Big Bang or evolution convincing enough to warrant a belief in billions of years? Is there enough evidence for the Big Bang to warrant a billion-year-old universe? Well, let's look at the evidences commonly used to support the Big Bang. And they would include the redshift of starlight, cosmic background radiation, element abundance, and the education system in the media. That's probably the biggest evidence to support the Big Bang, the education system and the media. But now, let's look at the evidences that go against the Big Bang. And notice what they are. Redshift of starlight, cosmic background radiation, galaxy formation, spiral galaxies, supernova remnants, distribution of galaxies, first and second laws of thermodynamics, medium-heavy elements, star formation. And we can go on and on and on. How many of those are mentioned in textbooks? There really aren't. But notice this one thing. The evidence used to support the Big Bang, there's also evidence in the same things like the redshift that go against the Big Bang. All those are left out of our textbooks. Our students are only seeing selected information, not all the data. So let's look at some of this. The Big Bang. Here's the handy space answer book. 1998. This is how they describe the Big Bang. 15 to 20 billion years ago, a Big Bang or explosion occurred, creating the universe. The universe began as an infinitely dense, hot fireball, a scrambling of space and time. Now, we need to understand the Big Bang model. The Big Bang model is not like a dynamite explosion. That's not what it is. What the Big Bang model is, it's an expansion of space and time. So somewhere we start with a ball of matter and energy. Now, wait a minute. Here's the first problem. Where did that initial matter and energy come from? Well, I want to do something here real technical. And I might go a little faster than this. If I go too fast, I might have to repeat it here. Here's where that original matter and energy came from. This is heavy college stuff now. There was nothing there, no universe or anything. Then there was something. Is that too technical? But that's the only explanation we have. They call it a scientific term called a quantum fluctuation. Quantum fluctuation is just another name for magic. Now again, this universe starts with some hypothetical mass and energy and suddenly starts exploding or expanding. So it's a tremendous expansion of space and time. And the other thing we need to understand about the Big Bang model is there is no center to this universe. A what? No center? How'd that happen? Well, we start from a central point, but as the universe expands, space and time, there's nothing in the center. That is critical for the Big Bang model. All our galaxies are like on the edge out there, on the edge. An analogy, here's a rough analogy. You have a balloon, deflated balloon, no air in it. And you put all these markings on these dots on the balloon to represent galaxies. Then as you blow it up and up and up, the balloon expands. And what happens to all those dots? They stay on the edge there. And what's in the middle? Where really nothing, there's nothing in the middle there. That is the Big Bang model. It's an expansion of space and time. So does this sudden explosion of nothing into something sound like a miracle? Well, it might. Paul Davies, who is a physicist and an evolutionist, states in his book, The Edge of Infinity, describes the Big Bang this way. The Big Bang represents the instantaneous suspension of physical laws, the sudden, abrupt flash of lawlessness that allowed something to come out of nothing. It represents a true miracle. Now, why is that any more scientific then than in the beginning God created? It's not. Matter of fact, it's even less scientific. But yet, we're being forced to believe it. So, let's take a look at one of these evidences that is used to support the Big Bang and also used to go against the Big Bang, the redshift of starlight. Now, we have this light spectrum out there. And on our light spectrum, we have two ends of it. One is the blue side, ultraviolet, and the other side is the red side, or infrared. Now, what I want to do here is describe what we mean by redshift of starlight. And let me give you an analogy here. Well, how this is going to happen. You have a car approaching you. Car approaches you and it has its horn on. And its horn stays on. And as that car approaches you, what happens to the pitch of the sound? Well, it gets higher and higher and higher. Why? Because as it's approaching you with the horn on, the sound waves get compressed and the pitch goes up. But once that vehicle passes you with its horn still on, what happens to the pitch of the sound? Well, it gets lower and lower because the sound waves are now being stretched. Well, light waves do the same thing. As a light source is moving towards you, the waves get compressed and the light will show up on the blue side of the spectrum. Now, we're not saying the light is blue, but the elements will show up as a line on the blue side.